Each and every sport contains its own set of biomechanical movements, which allow athletes to perform the actions required for the sport. As stated by the AIS, biomechanics is the examination of the forces acting on the body and the effects of these forces. If we, as biomechanists, are able to better understand the human body and the forces that we inflict and are inflicted upon us, the better we will be at implementing better techniques that will allow us to emphasize and make the most of these forces. The AFL drop punt is the most common type of kick used in the Australian Rules Football League due to its accuracy, distance, and ease of execution during gameplay. It consists of 6 components. The first component is the run-up, which is where the athlete will increase their stability, the accuracy of the kick, and the force transfer to the ball. It will enable the athlete to create greater force throughout the entirety of the kick. The second component is the planting of the support leg. The support leg absorbs the force generated by the speed of the run-up, thereby increasing the force generated in the kicking leg. The plantar flexion of the support foot will push the body away from the ground, which will add vertical lift to the kicking foot, which will then increase the force of the kick. The third component is the ball drop. The most important aspect of this phase is the contact time with the ball. The ball should be dropped at approximately hip height and should run along the line of the kicking leg. Another important part of the ball drop is trunk position. A forward-leaning trunk will produce a less powerful but more accurate kick, whereas a backwards-leaning trunk will decrease both control and accuracy. The fourth component is the leg swing. This is where the athlete will increase the speed of the foot before collision with the ball. Anthropometry comes into play during this component, as the leg mass and leg length will affect the amount of force that can be generated by the athlete. An athlete with a larger leg mass and leg length will be able to generate a greater force than an athlete with a lower leg mass and leg length. The fifth component is impact. This is the actual foot-to-ball contact phase, where the athlete will need to have their toes pointed and their muscles tight to ensure that the ball hits the foot at the right point. Contact should occur on the instep rather than out towards the toes to reduce the absorption of energy in the foot. Again, anthropometry comes into play as a larger foot mass will produce a further kick. Stiffening of the joints at the point of impact will also increase the effective mass of the foot by incorporating some of the weight of the leg. The final component of the AFL punt is the follow-through. Now, this component doesn't really have a great deal to do with the outcome of the kick, however, it is able to show coaches or trainers flaws in the kicking action. A performance criterion is often used by biomechanists and coaches to lay out the possible variables that may influence a movement. They are very useful in establishing the biomechanics behind a movement and allows coaches and trainers to better implement different techniques to enhance an athlete's ability to perform that particular movement. The main features of the AFL punt performance criterion are the path of the ball and the accuracy of the kick. There are many factors that come into play in regards to each of these features. Variables such as the athlete's anthropometry, hip and knee flexion, and the ball drop are all critical in executing a perfect kick. There are several biomechanical principles involved in the drop punt. Surface friction occurs when two surfaces come into contact with one another. AFL players generally wear studded shoes to improve this surface friction. The Magnus effect describes the force employed on a rapidly spinning ball that has been projected through the air. This force is responsible for the curvature along the flight path. In AFL, the backspin is an important aspect of the Magnus effect and the overall kick, as this allows the ball to be propelled a further distance. Sequential summation is another biomechanical principle used in the AFL punt. This is where the body parts chronologically move in the correct sequence, which is heavier body parts first, to produce the kicking action. Newton's first law of motion states that an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law can be implemented to the AFL punt in that the football will continue in the downwards motion from the ball drop until a force is acted upon it by the kicking foot. The distance that the ball will travel is determined by the force inflicted upon it by the kicking foot. This is where Newton's second law of motion comes into play. Newton's second law states that the force acting on an object is equal to the mass of that object times its acceleration. We can calculate the force of the individual's kicking leg by using the athlete's total body mass and timesing it by the average percentage of total body weight for a male leg. This gives us a leg mass of 14.68 kilograms. Using the distance from the furthest point on the leg swing to the ball and the time that the leg swing takes, we can find out the velocity of the leg, which is 3.38 meters per second. Using this data, we can find out the leg's acceleration, which is 21.09 meters per second. From there, using the athlete's leg mass, we can find out the force that is being produced by the kicking leg, which is 309.6 newtons. Using the same formulas used for the leg velocity and leg acceleration, we are able to find out the ball velocity and ball acceleration, which is 5.43 meters per second and 45.25 meters per second respectively. Using the formula for final velocity, we can find out the final velocity of the ball is 6.35 meters per second, which shows a 0.82 meters per second increase between the initial velocity and the final velocity of the ball, showing that the ball increases in velocity outside of the camera shot. Whilst the ball is in the air, it is referred to as a projectile. It is then exposed to a force known as projectile motion. This means that whilst the ball is in the air, the only force inflicted on it is gravity and possibly air resistance. Some errors that have been noted in the athlete's technique are their lack of flexibility. Their hip and knee flexion in their planted leg should be greater, and the knee flexion in their kicking leg should also be greater. This flexion is a key aspect in the AFL punt technique as it decreases the risk of tears in the corresponding muscles. The athlete has very little flexion in these areas and is therefore putting himself at a higher risk of muscle tearing. Flexion of the hips and knees also improves accuracy and stability and promotes the swinging of the kicking leg. Without this flexion, the athlete is impairing his accuracy, stability, and also greatly limits his leg swinging ability. The other error that is noticeable in the athlete's technique is the angle that the ball is projected away from the foot at. As we can see, the angle is 33 degrees, which is a considerable difference from the optimal 45-degree angle with maximum velocity. The main intervention that will be used to improve kicking technique will be feedback, mainly in the form of video feedback, as this will enable the coach and athlete to visually see the areas that need to be improved. Analysis software will also come in very useful, as it will show the errors in flexibility as shown in the previous slide. The training mechanisms that may be used to improve these errors are flexibility training and repetition kicking. Flexibility training such as stretching and doing exercises such as squats will enhance the athlete's ability to perform an accurate kick due to increases in their hip and knee flexion. Once these issues have been corrected, the best way for the athlete to improve their kicking technique is to implement their skills into match-like scenarios. This enables them to perform the kick in different match situations and prepares them for any kicking situations that may arise during the game.